Hello, welcome back to another video. We were looking at functions for mathematics paper 1 grade 12. So today we'll be looking at November 2018 question 4, right? So let's get started. Question 4 says that in the diagram below, the graph of f of x is equal to ax to the power 2 is drawn in the interval x is less or equal to 0. So these are your values of x from 0 in that direction. And then it also says that the graph of f to the power minus 1, which is the inverse of f, is also drawn. And then it says p, which is point p, which is minus 6 and minus 12, is a point on f, and r is a point on the inverse of f. So, okay, let's look at 4.1. It says it asks us to it's saying it's asking actually, is f to the power minus 1 a function? Motivate your answer. First of all, what is a function? Let's just start there. So let's just create some notes first to describe a function, right? Function, what is that? Okay, so a function in mathematics is a relationship between the inputs and the outputs. So for one input, you have a corresponding output, which could be one output or different outputs, but for each and every one output, corresponding output, right? So this is a relationship. Okay, so what is the relationship? So for example, let's say this are your x values, and then you have elements here, x1, x2, x3. So when you advance in mathematics, you call this something else. Those we know, you call it a matrix, right? So when you have a set of values like this, actually call them vectors in some cases, or just a vector. So you have your y values this side, right? So we know our functions, mostly we use these x values as our inputs. So these are our inputs and these are our outputs, right? So the way it works is that for this our input, you have another output, or sometimes you can have this output, right? You can have one or more output, but you never have something like this going to one, x value going to that, right? So it's rather one to many or one to one, starting from here to the right? So it could be this, it could intertangle like that, but it's always from one corresponding x value to one or more corresponding y value. That's a function, right? So we get that in theory, but when we draw a graphs, how can we tell functions from each other, right? From graphs that are not functions, because your graph doesn't mean that it's necessarily a function. It could be a graph but not a function, right? You have a g, you have a f. I will explain what I mean by that. So this is your h, right? Exponential, parabola, and a straight line. These are functions. Why? For each x value, you have a corresponding y value, right? And there's also something we call the vertical line test. When you draw a vertical line in your function, across your function, right, you intersect at one point. So for the straight line, you have that point. For the exponential, you have that point, and for the parabola, you have that point. So that passes the vertical line test. What is it? A function. So what does something that is not a function looks like, right? When you talk about graphs, right? So something that's not a function, if we go back this side, it's something that does not have one corresponding value to one or more corresponding values. It could have more, have what, more inputs in what corresponding to one to one or more outputs, right? So how does that look? For example, let's give an example about this. Let's give this, right? If you look, this is your x value x1, right? Here, this value is x1, you have x1, but so this coordinates are x1, y1, this is x1, y2. You see, the same y value correspond to the same x value correspond to two different y values, right? Which does not necessarily happen, right? You can have an x value here with a different y value and the same x value that side with a different y value. This side one you had one y value here with a different x value, y value this side with a different x value, right? Uh, so that's what we had, right? So but you can have one y value with different x values, right? But when you have one x value with different y values, it's not a function. So this, I know it could be confusing a little bit, that's why you really need to revisit it over and over again. So when we do the vertical line test, you cut it here, you have this point and this point. It fails the vertical line test. Why? Because you cut the graph at 2 points, or you intersect the graph at 2 points, and this side was only 1 point. So this is not a function, but this is a function. So not a function, right? So that's how you that's what a function is, right? It's a relationship between the inputs and the output for one x value, right? For one, and oh yeah, I think I made a mistake here, right? Because you only have for one y value, for one x value, you have only have one corresponding y value. But for one x value, you can have the same, what is this? The same y value. But so for a function, you have one x value, one y value. You can have the same x value, you can have this in the same y value for two or more x values, right? That happens. But for a non-function, the x values could be the same, having two or more y values, right? So yeah. So let's answer our question. So it says it asks us. So what we can do is we can just draw a vertical line test through f. Mine f to the power minus 1 actually. So let's do that. So yes, let's just draw that. When we draw it, we see that it only cuts the function here, right, at one point. Therefore, we can say that this is a function, right? Okay, my pens are giving me a problem, but let's, okay, we can get started now. So this is our answer for 4.1. F minus 1 is a function. So it's actually the question was, is it a function? So we can just write yes. What's the reason? This case passes the vertical line test. Right? Or your reason could be for one x value, there's a corresponding y value, right? So we're done. So by saying that it passes the vertical line test actually answers the question. So you can just write that, it's fine. So 4.2, what is the question for 4.2? So 4.2 asks, if R is the reflection of P in the 4 and the line y is equal to x, write down the coordinates of R. Okay, so let's just do this. when we say that a function is an inverse of another function, what we mean is that the original function, in this case f of x, was reflected about the line y is equal to x to get the inverse, right? So this is actually also a mirror. It mirrors this, so it's also an axis of symmetry, right? So the y is equal to x is an axis of symmetry, also reflect the function. So we know that when we reflect the function to get the inverse, there's an interchange, right? So what happens is that the y values become the x values and the x values become the y values, right? So I have an interchange of something like this. So for example, for point A, if we had x and y, therefore for the inverse of that, you will have f, you will have y and x, right? So here they're saying that what R is a reflection of P and the line y is equal to x. What do we get? We interchange because y is equal to x. It also just says that y is equal to x. Therefore, R will be minus 12 minus 6 because this is a reflection of P and the line y is equal to x, right? So let's just look at 4.3. What does 4.3 want from us? Calculate the value of A. So, okay, let's just do this. What was A? So A is from f of x is equal to ax to the power 2. What can we do? We can substitute point P because point P is on the graph of f, right? So let's just confirm that P, yes, it's on the graph of f, the blue graph. So it goes like this. We substitute point P, which is minus 6 and minus 12, right? So you will have minus 12 because that's your y value, and then you have a, and then you have 6 to the power 2. So this is a multiplied by 36. Alright, 6 to the power 2 is 36. So a is equal to negative 12 actually, over 36. This is 12 divided by 36. I think it's 3. Just confirm that. Yes, it is 3. So therefore we can simplify this and write it as 1 over 3. Okay, thank you, we got that. So we got A. Then we can go to 4.4. Okay, so let's just look here. Our graph is this. So yeah, we can confirm that A is definitely a negative. Why? Because we have this concave down like that, right? So this is actually a cut. So the original graph went something like this. So yeah, it's definitely minus 1 over 3. It's definitely negative. It could not be minus, it could be not be 1 over 3 for sure, but it's definitely negative. So we can be confident that is negative 1 over 3. So you say write down the equation of f to the power minus 1 in the form y. So that is the inverse, right? So we know what f of x is now. It is negative 1 over 3x squared, which is y is equal to negative 1 over 3x squared. You want to interchange because we want to find the inverse. So you will have x is equal to 1 over 3 y squared. um, we can isolate y, so we can just have y squared is equal to, so you can do that by dividing by negative 3, so that will just give you what 3 this side, because this is the same as multiplying by minus 3, right, to get rid of this function there. So we do that. Y is equal to plus or minus, because we put that under uh, put that under square root. So we did find that our function here is what it is greater or equal to, it's less or equal to 0. So we we can just do what we have x values that are greater or equal to 0, so we can just indicate our domain. So if you put 0 here, right, you will get an answer. If you put a negative answer, a number, you will get an answer. But a positive number, you will have a negative root. That is not possible. So that's why you do need to indicate your domain. Okay, so this is your domain, your set of x values where your graph is defined. Therefore, we have something like this. That is your answer. So yeah, we're done with this question. Question 4. If there's something you need clarification on, maybe the explanation on what functions are actually are, you can drop something in the comments, right, to actually understand more. So let me just revisit that. So a function is actually a relationship between the inputs and the outputs, right? So for one input, you have one corresponding output, right? But it is possible that for two inputs can have the same output, right? So what actually happens is that you see this line, it's not possible for another line to go to another y. This is not a function when this happens, right? So you need to remove this, right? But it is possible that this one, instead of going to y2, it can go to y1, right? So you can have two inputs for one output, but you cannot have what? You cannot have two output for one input. That is not a function, right? So yeah, and then we answered that. So for one y x value, there's a corresponding y value, a reflection about the y is equal to x, y is equal to x, y is equal to x. So that makes sense that your x values become your y values, your y values become your x values. That's the inverse. We found a as negative 1 over 3. We found the inverse in the form of y as plus or minus negative negative 3x, but this is only defined for x is less or equal to 0, right? So that's what we have. I think we can also do something about this negative plus or minus negative, because as you can see, your function here, it's only negative values in this direction. You don't have anything at the top there, right? So we can what we can do is we can get rid of this plus and just leave that minus there. That's our x value, that's our y values, they're all negative, right? So yeah, that's what we have for this question. See you next time.